In this course, you are going to be learning about pipelines that are one of the backbones of building scalable data engineering solutions in Microsoft Fabric. This video consists of 12 lectures that cover a range of topics from fundamentals to more advanced concepts like metadata-driven pipelines and best practices. So, in a nutshell, this course teaches you all the necessary things to start building your own production-ready pipelines with best practices. And by the way, if you're new to the channel, my name is Alexi and I'm a data architect and a Microsoft Fabric MVP, and on this channel I cover Microsoft Fabric related topics. And now let's start our learning journey to one of my favorite tools in Fabric that I use daily to build data solutions for my clients: pipelines. In this first lecture, we are going to do an overview of the pipeline tool and cover briefly the core concepts of it. And don't worry if all the concepts are not that clear to you after this first lecture, since we are going to come back to them in following lectures. The goal of this first lecture is just to get a general idea what kind of item pipeline is in Microsoft Fabric. Let's get started. Let's start by talking about what this pipeline tool/item is all about. Here on the screen we can see the data pipeline development canvas that is used to build data pipelines in Fabric. Data pipelines are built by adding activities to this canvas, and here we can see some example activities that have been added to the canvas. Also, there are many more activities that can be added from the top bar, and the data pipeline tool integrates very well with other Fabric tools like notebooks and data flows and can execute them as part of its execution flow. Also, it can execute actions in some Azure services as well, like a Databricks notebooks, Azure functions, Azure Data Factory pipelines, to name a few services. As you can probably guess from the UI of this tool, this is a no/low-code tool that is mainly operated using this drag and drop interface. And key thing to point out is that this tool is mainly for data movement and data flow orchestration. And it is very limited with data transformation capabilities. And those transformations can be done with other Fabric tools like notebooks and data flows, and then they can be executed as part of the data pipeline. And then they will do the data transforms that are required in the part of that pipeline. In this tool, you can define dependencies for different activities in the pipeline. And the most typical way is to define that some other activity is executed after the previous activity has been executed successfully. And these green arrows on this example represent those dependencies. There is also a possibility to define some other dependencies. For example, that some activity is executed after the previous activity has failed. And on this canvas, we have that Office 365 Outlook activity that is defined to be executed if the copy data activity fails. These dependencies on the data pipeline make sure that these activities are executed in a logical order. This tool supports using parameters and variables that allow building extra logic to the data pipeline. And since this is a data flow orchestration tool, it can be of course scheduled and triggered. But yeah, here we talked about some of the core features and functionalities of data pipeline tool, and now let's dive a bit deeper into them. Let's start with activities. Like mentioned, these are the building blocks of the data pipeline, and without activities, the data pipeline doesn't really do anything. Microsoft divides these activities into different groups, and those are data movement activities, data transformation activities, and control activities. To be honest, I'm not the biggest fan of how these activities are grouped into these different categories, since it is a bit confusing. But basically, the copy data activity is the only one that is classified as data movement activity, since it can copy data from source A to B. Then we have those data transformation activities that include activities that do some type of data transformation, like execute Fabric notebooks and data flows or run stored procedure or SQL scripts. But the confusing thing is that copy data is also considered to be part of this category as well. Things get even more confusing when we talk about the last category, control activities. Here we have activities that control the pipeline logical flow like loops and if conditions, and then we have activities that help to build logic to the pipeline like set variable and get metadata activity. But then we have activities that I would consider to be data transformation activities like Azure Databricks and function activity. Luckily, these categories don't really matter that much. And if you're interested in checking out these, go look at the activity overview documentation on Microsoft Learn to see which activity belongs to which category. Like already mentioned, activities can run different Fabric items like notebooks, data flows, stored procedures, SQL and KQL scripts. And also it is possible to nest data pipelines, which means that in a data pipeline you can execute another data pipeline. Activities also extend to external services as well, and they can be used to execute things in an external compute environment like Azure Databricks or stored procedures in some external SQL database. Also, many different external data stores are supported, and you can copy data from them or into them with copy data activity. Also, there are some generic activities like webhook and REST that can be used to interact with APIs. However, most of these activities that do things in external systems that are outside of Fabric require connections to be made. So let's talk about those next. As the name implies, these connections or connectors are links to external systems and services. For copy data, there are already quite an extensive set of external systems to connect using a variety of authentication methods, and Microsoft is constantly adding new connections to choose from and new authentication methods to old connections. Also, some of the connections will require on-premises data gateway that acts as a bridge between Fabric and those external systems. Good thing to point out is that not all the same activities are supported for each connection. For example, some connections can be only used as a source and you can only copy data from them to Fabric, but not the other way around. Also, other activity support varies quite a bit. For example, some external database connections support running stored procedures using stored procedure activity and some not. Data pipelines also support passing external values into them via parameters. Parameters are very handy if you would like to build more dynamic data pipelines that can serve multiple purposes. Also, like mentioned, you can nest these pipelines, and with parameters you can pass information from a top-level pipeline to a lower-level pipeline. It can be mentioned that many different data types are supported for parameters. Also, there are variables in pipelines that can be used in a bit similar fashion than parameters. The main difference between parameters and variables is that parameters are used to get information outside of the pipeline into the pipeline, and variables on the other hand are defined inside the pipeline and has to be set during the execution using the set variable activity or default values. Like with parameters, variables support also many different data types, but options for different data types are a bit more limited compared to parameters. Pipeline parameters and variables can be referenced in other activities by using pipeline's expression language. This expression language allows adding more logic into pipelines and making them more dynamic. Very simple example of using this expression language would be by adding dynamically timestamps to file paths when copying data from an external system to Lakehouse's file section. Since the pipeline is an orchestration tool, it is obvious that it can be scheduled to run at set time intervals, and by default your new data pipeline doesn't have a schedule defined, and it has to be turned on and configured if you want to have one. Schedule supports configuring it from the minute level all the way up to the month level. Currently, both start and end date and time have to be defined, and those define the period during which the pipeline is active. Then schedule has also the option to configure the time zone that can be used to select the time zone for the schedule that automatically adjusts to summer and winter times if that specific time zone uses those. Also, a good thing to mention here is that we have the possibility to configure triggers as well, which means that we would trigger the data pipeline based on actions rather than schedule. But these triggers are a bit more advanced topic and we're not going to cover them here. Also, another topic that I just mentioned very briefly here is monitoring. Since pipeline can be also monitored from the monitoring hub, and there we can see information how a specific pipeline run went. But now it is time to open up Fabric and do some demos there. Okay, here I have the Fabric open and I have this workspace open that I'm going to use to demo these pipelines here. Let's start by clicking the New Item button here so that we can create a pipeline to this workspace. And here we have the pipeline item. Let's open that, and then we have to name our pipeline. I will name this PL first example pipeline, and then we can hit create. And this will then create that pipeline for us and open up this development canvas. Here we also have these options to start with guidance. For example, we can start with the copy assistant or practice with sample data, or we have some predefined templates that we could use. Or we can start with the blank canvas. For now, I will start with the blank canvas, so I will click this, and then we have to select the activity that we will add to that canvas. Here we can see this long list of activities that are currently supported by the pipeline tool. But now I will only add this simple wait activity here. That is a very simple activity that will just wait the amount of seconds that you have configured here. So now it's saying that we will wait 1 second here. And here we can see how does the pipeline development canvas look. So here in the Home tab, we can, for example, save the pipeline or change some settings related to the pipeline. And then we also have the possibility to define that schedule and also run the pipeline and also validate the pipeline. This validate button here is actually quite handy, and you can use it to validate your pipeline and check is everything configured correctly so that you don't have any authoring errors in your pipeline, and it would basically run if you would hit the run button. But now if I click this validate button, it says that your pipeline has been validated and no errors were found. That's because we just have this simple wait activity. But if I would remove that seconds there, now this would have an error, and we can click validate, and now it tells that wait activity, wait time in seconds cannot be like basically empty. But yeah, now I can click close and we can add that 1 second back there. And like I said, we have a bunch of different activities that we can add to the pipeline. And here we have this dedicated activities tab where we can find even more of these activities. For example, we have data flows, notebooks, that are these other items in Fabric, also copy jobs. So that's why, like I said, data pipeline is a great orchestration tool. So we can use it to orchestrate our whole data solution in Fabric and run those different items that are required for our data processing. Then we also have these activities that we can use to add this kind of a logic to the pipeline. For example, some if conditions or ForEach loops if we want to loop some activity here in the pipeline. And then we can connect these activities by using these dependencies. And like I said, there are also other dependencies than these on success dependencies. For example, there is this like a fail dependency and so on that can be used. For example, I can change this if condition to this copy job with that fail dependency. But yeah, this way we would start to build our pipeline. We can also create multiple branches to the pipeline by branching from one activity to 2 different activities. So in this case, for example, we would first execute the wait activity, then data flow, and after that, we would execute the script and a notebook at the same time, since they both execute after the data flow has been executed successfully. And here in the 3 dots, we can find the whole list of activities that we have available here. And many of these activities are probably activities that you use very rarely, but one of the most commonly used activities is the copy data. Then I would say that these kind of conditionals like if conditions and also control flow for each are very used activities. And then you have these activities for using the variables in the pipeline. Also, like I said, we can nest pipelines on top of each other and we can add these invoke pipeline activities. And here we would have to specify the pipeline we would like to invoke. But yeah, let's remove these activities here for now. And let's add one copy data activity here so that we can talk about connections. So here we have these source and destination tabs. And these source and destination both require a connection. So if we click this arrow here we would be able to browse all the connections that are available to be configured. For example, some new sources that we have here. And here we have a long list of different systems that we can connect to using the data pipeline tool. And for example, we could fetch data from Salesforce, Oracle, FTP, or Snowflake, or any of these systems that are basically here. And this would require us to define a connection to that specific system. For example, if we would use the Amazon S3 bucket as an example here, I would select it, and then we would have to fill in the connection info that is required in order us to connect to that specific external system. I'm not going to configure this connection right now, but basically you get the idea that we would first configure, for example, one connection for our source, and then we would create a connection for our destination. For example, that could be an internal system like a lakehouse here in Fabric where we copy data from that S3 bucket. And like said, we can define parameters to the pipeline so that we can pass some external values to the pipeline when it executes. Here we can, for example, define one parameter and call that ABC, and we can leave it as string type. And then we're able to provide a default value for that parameter. And after that parameter has been defined, we would be able to use it as part of the data pipeline expression language. And this expression language can be accessed by using this dynamic content that will appear in many places when you select a specific field. And here, for example, we can click this add dynamic content, and here we would be able to start the expression logic for this value that we have here. Of course, now the expression logic would have to evaluate this kind of an integer value, because this wait time seconds is expecting to have an integer value. But for now, we are not going to dive too deep into this expression language and different functions that we have here. But basically, it's good to know that now the parameter would be available here and we would be able to use that. But we will come back to these expressions later on. Also, another thing that I want to show you quickly is just that this pipeline is actually a JSON definition on the background. So if we click this edit JSON, we can see this JSON that actually defines this pipeline. So for example, here we can see the pipeline name, and then we have this array, and here are the activities that we have in this pipeline. For example, here we have the block for the wait activity, and here we have a block for that copy data activity, and also the parameters and everything related basically to this pipeline is found here. But like I said, this is a bit more advanced topic and how to use this, but if we would put this pipeline to a version control, you would basically see this pipeline as this JSON template there that we can see here. But this is something that you can keep in mind for now, and we're not going to discuss this further now. But yeah, let's remove this copy data here. And we can go to the Home tab, and here we have this Run button. If I would click this, this would trigger a run for this pipeline. So we have to first save, and then we can run this pipeline. Now it will save it, and it will now run it. And now we would have to define the value for the parameter. Of course, this doesn't really matter what we define here because we are not using this parameter value in anywhere in this pipeline, so I can add just some random letters there and click OK. And now the pipeline will start to execute, and we will soon see some output in this output tab here when this will start to execute. And it should just execute that wait activity, so this should be very fastly executed, and now it is already done. And here we can see that the wait activity succeeded. And then we can go to the Fabric Monitoring Hub, and we should also see this run there. So let's open up the Monitoring Hub. And here in the Monitoring Hub, we can see this first example pipeline. Actually, now the status is not started. I think this Monitoring Hub lags at least few seconds behind, and maybe soon the status should be succeed, but it will change here. But basically here in the Fabric Monitoring Hub, we would be able to monitor our data pipelines. And I also have already few other pipelines running in this same workspace that we can see here. And one of those pipelines is failing and the other one is succeeding. But yeah, those are running by using the schedule that we can configure the pipeline. So if we go back to the pipeline here, we would be able to configure that schedule and add a schedule to this pipeline. But this is something that we're not going to do in this lecture. But yeah, let's close that. In this lecture, we're learning about copy data. That is one of, if not the most important activity to learn and master. We're learning about the function of copy data in pipelines and its different capabilities and limitations. And then we are going to learn how to use it in practice to copy binary and CSV files. And by the way, if you have been enjoying the content so far, I would really like you to hit that like button and also subscribe to my channel for more Maxed Fabric content. This doesn't cost you anything and I would highly appreciate that. But now let's cover copy data activity. So copy data is one of the many activities that we can add to the data pipeline, and I would argue it is probably one of the most used, if not the most used activity in the pipeline tool. Here on the screen we can see how does the copy data activity look in the pipeline UI. Let's first talk about the purpose of the copy data activity, which is, as the name implies, copy data from place A to B. In the context of copy data activity, place A is called source and place B is called destination. Let's dive a bit deeper into these sources and destinations in the copy data activity. With copy data activity, data engineers can move data between two different data stores. These data stores could be fabric data stores like data warehouse, lakehouse, or event houses. Or they could be some external data stores or system from which the data is copied or copied to. This makes a copy data an excellent data integration tool for many different scenarios. Next, let's cover binary copy. Copy data activity can copy data in binary format, which means that it can move data without caring what type of data it contains. So this means that copy data can basically copy all types of data when using binary copy setting, since it treats those files as binary blocks without reading the actual data inside the file. You can think of this case like copying just some files on your local computer from one folder to another. And of course, there is a possibility to copy those files and leave the original files to the source, or delete those source files after the copy has been executed successfully. Binary copy is typically used when ingesting data to Fabric from some other data store that stores raw files like Azure Blob Storage or AWS S3 bucket. When speaking in medallion architecture terms, binary copy is common in bronze layer data ingestion. In these cases, you typically want to store raw files to Fabric in the original source format before doing any data transformations to them. Also, when copying files, a file format can be specified, which then opens up more options in the copy data activity. For files, copy data supports using many of the most common text-based file types as sources like CSV, or more correctly said, delimiter text files and JSON and XML files. Also, some more advanced binary file types are supported as well, like Parquet, Org, Avro, and also Excel files. For destination side, some of the same data types are supported, but now the selection is narrowed a bit, since copy data doesn't support writing data to some file types that are available in the source side, like XML and Excel files. Also, when we expand our sources and destinations from files to Fabric data stores and external systems and data stores, we get even more possibilities to use this copy data activity. As you can probably guess, the copy data can transform the data format when copying data. For example, copy data from on-premises SQL Server database table to Delta table in Fabric Lakehouse or vice versa. Basically, you are able to mix and match these sources and destinations however you like and is needed for your use case. Even though copy data is not really a data transformation tool, and there are many better tools in Fabric for that purpose like data flows and notebooks, it still has some limited data transformation capabilities. Like discussed, copy data allows you to change the data format, for example from a flat file to a delta table. Also, copy data allows changing column names and data types by using the mapping feature. Next, let's go to Fabric and do a little demo about the copy data there. And now here I have this blank pipeline development canvas open, and to this canvas I will just add one copy data activity. And also in this same workspace I have a lakehouse. Let's open up that, and in this lakehouse in the file section I have this source folder, and in this source folder I have this movies.csv file with few rows of data. And now I would like to copy this movie CSV file to another folder in this file section. So basically I would like to create a destination folder and copy this movie CSV file to that destination folder as a binary copy, so that we don't really need to care about the data inside the file and we will just move it from the one folder to another. So let's go to our pipeline. And here in the source side, we want to configure the connection. When you are working in the same workspace, you don't have to define the connection. So I will select this none, and then I will select the lakehouse here. That is the lakehouse that I'm using to demo this. And then I want to select that I'm using the file section of the lakehouse. And already the binary copy is configured there by default. We have also other options here that we can use to read different types of files, but for now I'm going to use the binary setting there. And now I would have to define the file path from which I'm going to take that file. So let's go here, and then we can navigate the file section of the Lakehouse, and here we can find the source folder, and in this source folder we have that CSV file. So I will click OK. And now we have configured the source side of things. So we are reading this one movie CSV file from the file section of the Lakehouse and from this source folder. Next, let's configure the destination side. So here as well, we don't need to define the connection, so we can leave it as none. And then for the item, we are going to select that same Lakehouse. Of course, this could be now a different Lakehouse in this same workspace, but for now I'm just using the one Lakehouse because it's simpler and I don't have to create additional items to this workspace. And again, we are going to copy to the file section of the Lakehouse. And now actually I'm going to write the path where I want that file to be written, because if I would click browse, we don't have that folder for that destination. So I will write here destination, and then I'm going to write the file name here. And actually now we could change the file name here. When we copy that file, we are able to change the file name if we define the file name here. But if we don't define the file name here, it will actually keep the same file name it had originally in the source folder. And now for the file name, I will add this movies_copy.csv. And now we have also configured our destination side of things. So basically now we would be able to run this pipeline and see what happens. So let's click this run button here, and this will then save and run our pipeline. And now it should be running shortly, and then it should do that copy for us. And now the copy data has run and it succeeded. So now basically we should have that file in that other folder. But before we take a look at that, we can actually click this activity name here in the output to see more information about the copy data, what happened there. So basically here we can see that how many bytes of data we read and how many bytes of data we have written, and also how many files we have read and how many files we have written. And also here we can see some more information about the copy activity, that what happened there and how long everything took. But basically now we are not going to browse this more, and we can close this, and we can go to the Lakehouse and we can refresh this file section here, and now we can see this destination folder here. And in this destination folder we have that movies_copy.csv, and if we open up this should have the same contents, and it has those 3 rows plus the header that was in the original file as well. Because we did the binary copy, we didn't have to really care about the file content. And basically this CSV file could have been, for example, audio or video file, because we are just copying data as binary blocks without caring about the contents. And now let's create another pipeline, and let's do things a bit differently this time. So let's find the pipeline here and let's create that, and let's call that example 2, and then let's create that. And then again, let's add copy data activity to this canvas. And again, let's select that same Lakehouse we used previously. And this time also let's use the file section. But this time let's use the delimited text file, meaning that we are going to read the contents of the file. Delimited text file is basically for using any type of this kind of a flat file. Typically it is for CSV files, or the CSV file is the most common name used for delimited text files. And now let's find that same file again on the source side. It should be here. Yeah, there is the movies.csv. And now we would be able to click this preview data button and see how this copy data is reading that specific data in that file. So here we can see that the data looks good. We have 3 columns here, and then we have those 3 rows there. If the data wouldn't look good, then probably the configuration for this file would be somehow wrong. And here we have these settings where we can actually change the configuration. For example, if we have a different delimiter or we don't have a header, we can configure these kind of things here in the settings. But for now, I'm using that standard CSV file, so we don't need to touch these settings, and we can click cancel. And now actually I would like to copy this movies.csv file to the Lakehouse table section. Actually, I already have a movies table here that I copied there before I made this video, but now we could copy this same movie CSV file to another table in this same Lakehouse. So let's do that. So let's go to the destination side, and now we are again selecting that we are not going to use any connections since we are within the same workspace. We're going to select the same lakehouse, and now we're actually going to select the table section. And now I'm going to manually enter the table name to which table I want to copy this movies file. So let's just say that we're going to be copying to movies copy named table. And here we can configure some things about that table. Would we append the data to that table, or would we overwrite the table, or would we do an upsert? So basically track some changes. But now I'm going to select the overwrite option. So basically every time we would run this pipeline again, we would overwrite the table with the new data. Also, we have more advanced settings here that we're not going to talk about right now. And now basically we would be able to succeed in the copy that we would do and copy the contents of this CSV file to this lakehouse table. But we have also this mapping section that we can use to change the column names and data types a bit. Here we can click this import schemas, and now it will basically read the contents of the source file and also read the contents of the destination table or come up with them since we don't have that table there yet. And here we would be able to change things. For example, we could say here film is something else. For example, we could type here that it's now called movie like this. And now the column name would change. Also, we would be able to change the column data types if we want. For example, if we check the data here we could see that we can set, for example, integer values for this year, because in the CSV file everything is basically text before we say that we want to transform the data type to something else. So we can change this to integer, and this we can change to some decimal data type. So let's go there, and for example we can change this to integer, and this we can change to, for example, to double. And now we can click this validate button and see that is our pipeline valid, and we are able to run it. So now the pipeline has been validated, and we can click this run and click save and run, and this will then run our pipeline, and then we should have a new delta table in our lakehouse, and we should have those tiny changes made to the data. So now I'm also demoing these very limited data transformation capabilities of the copy data, where we can basically change some data types and rename columns, and in some cases also add some additional columns here. If we would like to use this advanced tab here, we have the possibility to add additional columns, but these are a bit more advanced topics that we're not going to discuss in this video. But yeah, now it has already succeeded, and we can again click the info and see that we have read one file and also written one file, and rows match there. So probably everything went just fine. So let's check out the lakehouse table section. We should have a new table there called movies copy, and let's check out the contents of this table. So now we should have those tiny data transformations applied here once the table loads up. And here we have the table. So the film is now a movie, and then the year is now integer value. We can see that 1, 2, 3 there, and then the rating is now double. So I would say that everything went as we configured them, and our copy data activity / pipeline worked very well there, and our configuration was correct. In this lecture, we're going to be learning about connections that allow pipelines to interact and fetch data from external systems. So we're going to be learning about what connections are and how they can be created and managed. Then we go through some of the typical authentication methods used in connections. And of course, we are going to learn how to use connections in practice. But before we do that, I want you to know about CertiAce. That is a platform that offers high-quality practice questions for Microsoft certification exams like DP700 and DP600. On this platform, you find huge question pools for each exam with many different types of questions that are very similar to those that you would have in the actual exam. Also, CertiAce has a very realistic practice exam with case studies that really help you to benchmark your knowledge and time management before taking the actual exam. So, if you want to save time from your exam preparation and ace your Microsoft Fabric certifications, then go to certiace.com. And by the way, I'm one of the co-founders of CertiAce, so some of the questions you see here are actually made by me. But now let's cover connections. Let's start by covering what is a connection in Fabric. Basically, connection defines how Fabric accesses data and communicates with systems and data stores. Here we can, for example, see a pipeline in Fabric, and then we have an Azure blob storage. In order us to access the data sitting in the blob storage, we would have to define a connection to Fabric that our pipeline would be then able to use to get the files from that blob storage. To that connection, we define all the required connection information that is needed. For example, authentication, that we can access that blob storage that is from the Fabric's point of view an external data store. This means that in the pipeline itself, we just use that connection, and that same connection can be shared by multiple pipelines. Also, it is good to know that there are internal connections as well, and we can use them to connect to Fabric data stores or run other Fabric objects in a pipeline like other pipelines. Connections are not only limited to pipelines, and they can be used in other Fabric items too. For example, copy job would need connections to do its copy operations, and also Lakehouse shortcuts require connections. But since we are now only focusing to pipelines, this is just something that is good to keep in mind. Let's now quickly discuss some of the different authentication methods you might be running into when dealing with connections. I will use connection to Azure Blob Storage as an example. The simplest authentication method is anonymous, which means that there is no authentication. You almost never run into this in real projects. Typically in sources, and in this case blob storage, we have some level of security and authentication that is required. And in that case, we need to do some authentication when accessing the blob storage. One of the most simple ways is to use storage account key, but this is typically very bad since it is basically a password to the entire storage, and this method is far from optimal. Then we have shared access signature or SAS token that is a bit better than the key, since we can limit the scope and set expirations, etc., but still not typically optimal. Then we have OAuth 2.0 that basically means that the connection will use your personal credentials for the access. So you personally need to have access to that blob storage for the connection to work. This is quite secure but not optimal since the connection is tied to your personal user account. That is completely another can of worms that we're not opening in this lecture. Then we have our preferred and more optimal methods. First, we have service principal, that is the Entra ID based authentication like the OAuth 2.0, but it is using a technical account and not someone's personal account. Then we have the Fabric Workspace Identity that is very similar to Service Principal, but it is automatically created for the workspace, so no real setup is needed for that one. With Service Principal and Workspace Identity, there are their own strengths and weaknesses that we're not going to cover here. And don't worry if you're a bit lost with some of these methods, since these are not really focused on in this lecture. And I just wanted you to know that in many cases when dealing with connections, there are multiple authentication methods that can be used. And when building real-world solutions, it is good to choose the most secure and convenient one for that specific case. Next, let's go to Fabric and learn more about the connections there. Now I have Fabric open and I have this blank data pipeline canvas here. To this canvas I will just add one copy data activity that we're going to use to build that connection that we're going to demo here. But yeah, I'm going to build a connection to this Azure blob storage that I have here. Basically this is an Azure storage account, and in this storage account I have one container. Here I have the Fabric Forge container 1, and in this container I have this movie CSV file. So I would like to build a connection to this container, and I'm going to actually use the access key that can be found here. And these access keys are basically quite a bad practice to use when building connections, but they are super simple, so I'm just using them for demo purposes. But now let's go back to Fabric and let's go to the source side, and now we are going to browse all the connections that we have here. So let's click Browse. Here we are actually going to view more, and here we have to find the Azure blobs here, and this is the connection that we are going to use. And now we would have to provide the storage account name or URL to which we are going to connect. So we can get name here from the Azure side of things, so let's copy the name and let's add it here, and then we're going to create a new connection, and here we have the connection name that is automatically created. We can now go with that, and then we are going to use the account key for the authentication. And this account key is found here, like I showed earlier, but remember that this is a secret and you don't really want to expose this, so you don't really want to show it on video like I'm doing right now, but this is just for the demo purposes, and I'm going to rotate this key after I'm done with this demo. So now we are going to use the account key here like this, and then we are going to hit connect, and this should be able to establish the connection to this blob storage there. And now the connection has been made, and we can click this test connection, see that does the connection work properly. This says that connection is successful, and now we would define the container we want and directory in that container at the file name that we want. But we can also click this browse button here and find the file that we are looking for. So here we can see that Fabric Forge container that we can also see by going here, and there is the container. So now I'm going to navigate here, and here we can find the file that we are looking for. So here we would select that movies.csv file. And now we would be able to, for example, define a destination, for example, our lake house in this workspace, and copy this movie CSV file there as binary. Or we can, for example, define that we want to read it as delimited text. So basically now we would be reading the file schema there, and we can preview the data, and we should see the movie CSV data here when this preview loads up. And we can see that we have those 3 columns there and 3 rows, and we can check the files here and see that it has the same contents there. And there we can see the same contents we can now see in the table format in the tool. So now we have successfully defined the connection, and we would be able to use this connection in this copy data activity and copy data over. And like I said in the theory section, this connection is not really tied to this pipeline, and this can be used across pipelines and also across Fabric tools. So this connection is seen here, but these connections also can be found by going to the settings here in Fabric and opening up these manage connections and gateways. And here we have the connection that we created there, so it now has the default name, and I could probably name it a bit better. But basically here we would be able to manage some settings for this connection, like see the connection ID, etc., and also change the authentication method for the connection. Also here we are able to manage the users who are basically able to access and use and modify this connection. But here is where you can find these connections once you have created them. And then this connection, like I said, can be reused across pipelines or Fabric items once it has been established. And like I said, there are far superior authentication methods compared to the account key that I was using right now. So basically in real world scenarios, I would prefer using service principal or workspace managed identity, but these are a bit more advanced topics, and using a key is just a very simple way of demoing things, because it's basically the password that can be used to access this specific storage account that we have in the Azure. But yeah, I hope this now taught you something about connections and how to make them. In this lecture, we're going to be learning about parameters and variables that allow us to pass and store information during the pipeline execution, and also add some dynamic logic to our pipelines. Let's get started. Let's start with parameters and imagine a situation that we have a lakehouse in Fabric, and in that lakehouse we have 2 files, f1 src.txt and f2 src.txt. And then we would like to copy these files to another lakehouse and change the src in the file name to dst. How could we get this done? Of course, there are multiple ways to achieve this goal in Fabric, but one of the simple ways would be that we use Fabric pipelines. We could create a Fabric pipeline and then add 2 copy activities to that pipeline, and then copy those files from our source lakehouse to our destination lakehouse. This setup is all good and fine, and it works, but we can use this as an example to demonstrate how we can use pipeline parameters to reduce the number of activities in this pipeline. We start by removing these 2 copy activities and replacing them with just 1 copy activity. Next, we would like to add 2 parameters with a string data type to this pipeline called source file and destination file. Then we can pass down these parameters from the pipeline level to the copy activity and use these parameter values dynamically decide which file to copy. For example, when running the pipeline, if we would add string f1 src.txt to the source file parameter and f1 dst.txt to the destination file, we would be able to copy f1 src file from the source lakehouse to our destination lakehouse with a different name. And by running the same pipeline again and changing the parameters value, we would be able to copy the other file as well without doing any modification to the pipeline itself. This is just a simple illustration how you could use parameters in pipelines to do things dynamically. Next, let's go through a few key points about parameters. The main functionality of parameters is passing external values to pipelines. Parameters can be literal, meaning some hard-coded values, or parameters can be expressions that are evaluated when the pipeline runs. In this lecture, we are not going to cover expressions that much, but it is still good to keep in mind that you don't have to use some hard-coded values when using parameters. Parameters can be very helpful and save a lot of development time when used correctly, since they allow adding dynamic logic, and they can be used in all the places that support adding dynamic logic that I'm going to demonstrate shortly when we open up Fabric. Also, as a last takeaway here, it is good to know that there are different data types available for parameters that are string, integer, float, boolean, array, object, and secure string. Next, let's talk about variables that are similar to parameters but different in a few key ways. Firstly, pipeline variables are values that are defined during the pipeline execution and live inside the pipeline, which is the key difference when comparing to the parameters, since parameters are values that are given to the pipeline and come from outside of the pipeline into the pipeline. The main purpose of variables is to add some extra logic to the pipeline and to hold some intermediate data for some processing logic purposes. Like parameters, variables also support default values, and if variables are not set using the setVariable activity, then the default value is being used as the value for that variable. Variables also support few different data types, however, compared to parameters, there are fewer choices. Currently, variables support 4 different data types, which are string for text values, integer for whole numbers, boolean for true or false values, and then arrays for list of items that could be any data type. The main activities used to interact with variables are the setVariable activity and then the appendVariable activity. With the setVariable activity, variables can be assigned hard-coded or dynamic values using expressions. The appendVariable activity is meant for adding new items to the end of array-type variables. There are also many system-type variables that are already predefined and hold some system-related information like pipeline name, pipeline trigger time, or workspace ID, just to name a few variables so that you get the idea. Next, let's go to Fabric and do some demos with parameters and variables there. Now I have this blank pipeline development canvas here, and let's just add one copy activity here and start to configure that by using parameters first. We can use this movie CSV file that I have in this Lakehouse file section to demo parameters a bit. So I will copy this movie CSV file to this destination folder with a different name by using parameters. So let's go back to the pipeline and let's start to configure this copy data activity. We don't need to use connection since we are within the same workspace, and then we're going to select the lakehouse, and then we're going to select the file section. And now I'm going to hard code or select the file name for the source. So I'm not going to use any parameters or dynamic content for the source. So we are going to use the hard coded file name, meaning that I will use this interface here to find that. And then we can click OK. And now the movie CSV is now hard coded to the source, and I'm going to use the binary copy here. But for the destination, I want to add some dynamic logic. But first, let's configure that same lakehouse there. So let's select that. And then I am going to select the file section, and to the directory, I'm going to actually hard code that destination directory. But for the file name, I'm going to actually use a parameter. And now let's click somewhere to the development canvas, and now the activity is deselected, and now we can see this parameters tab here. Now we can create a new parameter here. Let's call this destination file name, and then we would be able to select the data type for this parameter. As we can see, we have many options for different data types, but now we are going to use the string value because file name is basically a string value. And here we would pass that file name that would be created when we copy that data. And now let's go back to the copy data, and to the destination side, to the file name, we can click this field and then we can see this add dynamic content pop up. And now I'm going to click this, and this will open up the pipeline expression builder. And here we have a lot of tabs available that could be used, but for now we are only focusing on the parameter tab. And here we can see this destination file name parameter. And when we click this, it will automatically create this expression that is needed for using that parameter. So basically it is @ pipeline and then .parameters.destination file name. And this will then reference that parameter that we're giving this pipeline. So basically it will then dynamically change this file name field here when we run the pipeline with a different parameter. So let's click OK, and now we can see that the expression has been added here. And now we would be able to run this pipeline and add a different name for our file when we copy it to that destination folder. So if we now first validate that everything has been configured correctly, then we can click run, and then we have to save this, and then we can rename the file when we copy it. We can, for example, put here abc.csv, so the file name when after it has been copied will be abc.csv. And now I will click OK, and now the pipeline will start running and use this dynamic parameter here in that file name instead of hard-coded value. Now the pipeline has succeeded, and we can click more information about our copy data, and we can see that one file was moved, and then we can go to the lakehouse and we can confirm that in the destination folder we should have a new file called abc.csv, and there it is. And since we did a binary copy, the contents of the file didn't really change when we copied from the source to the destination. Also, one very handy thing to know when working with these parameters is how to use these activity inputs especially. So if we open up this activity input in this output, we can see what content actually went to this activity. Here we can see this JSON that could look a bit scary first, but basically this is just the configuration that was passed to that copy data when it executed. And here we can find basically that same information that we can see in the UI. So here we, for example, can see the configuration for the source, and here in the source we can see those hard-coded values that we added there, like for example that movie CSV that was hard-coded. But here in the sync we can also see that we had that ABC CSV, so here we can see the actual value that was passed down as a parameter for this activity. So here we can see how did that parameter value evaluate when that copy data executed. And also if you want to see how those are defined in the pipeline template itself, you can go to this View tab and edit this JSON code and see here the dynamic reference for that specific field. For example, here we can see the file name, and here we have the parameter expression. But these are a bit more advanced topics, but I just give them to you as a hint when working with parameters and getting better at working with them, that these JSON configurations and JSON inputs are very like essential when working with advanced parameters and dynamic content in general. Also in the activity output we can see what happened, but this is not really that relevant to that parameter thing anymore. But here we can see some information about the copy data. And now if I would run this pipeline again, I could use a different parameter and change the file name to something else, and then that name would be used when the copy data runs. But now I'm not going to do that. And before we are moving to the variables, I really want to discuss the core thing related to these parameters. That is this invoke pipeline activity. So with this invoke pipeline activity, we can invoke other pipelines. And here parameters are typically used to pass information from the top level pipeline to the bottom level pipeline. So when we are configuring this invoke pipeline activity and when we select a pipeline with parameters, we get the parameter fields to this pipeline here, and we would be able to put those values that we want to that pipeline that we're executing. So basically parameters allow us to build these kind of a more dynamic and multi-purpose pipelines that can basically fulfill multiple different use cases. For example, we could have a generic pipeline for doing these binary copies, and then we would just invoke that pipeline in other pipelines. But yeah, this is also a bit more advanced topic, and I'm not going to dive deeper into this in this lecture. So let's remove this here. And now I have a new pipeline development canvas open here, and now we're going to talk about variables that are very similar to parameters, but the key difference is that these variables won't be available if we invoke this pipeline from another pipeline. So we cannot see them here when we configure the invoke pipeline. So these variables live inside the pipeline, and they are not meant for bringing information from outside to the pipeline like parameters are. So they are like these kind of a typical programming variables that are defined during the execution. So here we can define variables. So let's first define, for example, variable 1, and then we can set data type for it. As you can see, the data types here are a bit limited compared to the parameters, but we still have some data types to work with. And then we could actually give some default value for our variable. And this would be then used if we don't set any other values for this variable. But if we would like to set some other value for this variable, we can use set variable activity for that. And this set variable activity allows us to set variable values. Here we can find the variable that was made, and here we have only that variable 1 because I only created one variable to this pipeline, and here we can use hard-coded values or dynamic content to set value for this variable. I could, for example, set a value AAA here that would be then used for that variable when the pipeline executes. And this would basically replace this default value that was set. And also, when we would run this pipeline like this, the variables are not given here like the parameters are when we are executing the pipeline, because they are defined during the pipeline execution, and the default value is then used if nothing else is specified. And now the pipeline will run, and it has already executed, and our set variable activity has run, and we can see the output of that activity, and we can see that now the variable 1 was set to value AAA instead of that default value. And also these variables can be referenced in the dynamic content in some other activities. For example, if we use this copy data here as an example and configure this a bit forward, we can tap this dynamic content. And here we can find variables, and here we have that variable 1, and this will create the expression that is needed for using that variable 1. So now if I would use this variable 1 here and it would be set to AAAA, then this file path here, the directory would be that AAA. But since I don't have that kind of directory in my lakehouse, this doesn't really make sense. But yeah, let's remove this variable 1 here and also talk about system variables. That are these predefined variables that we have here in the pipeline tool. Here you can find the list of these system variables that are available. For example, we have the pipeline ID, that is basically the technical ID for this pipeline, pipeline name, pipeline group ID, pipeline run ID, pipeline trigger ID, etc. So here we have these many predefined system variables that can be used here. For example, if we tap this pipeline name here, this would then use this pipeline name here. That is basically this PL parameters and variables example 2 when this executes. And we can actually click cancel and remove this copy data and, for example, set the value of variable 1 to that system variable by using this system variable here. So, for example, I can select this pipeline name here and then I can click OK. And now when this pipeline runs, this variable 1 value would be set to that pipeline name. So let's run this and let's see the value output for this activity. And now it is executing, and I think this should finish very fast since we are only running a set variable activity. And it is already completed. And we can use this output to see what that value was. And now the value of variable 1 is set to this pipeline's name. And now if we would reference this variable in the following activities, the value for that variable 1 would be this pipeline name. And typically these variables are used to build some extra logic to the pipeline in real-world scenarios. For example, when we need to hold some values and do some operations based on those values. But yeah, they just gives us some flexibility what comes to the pipeline tool and building more complex pipeline with it. But my personal approach is to keep things simple, and if I would end up to a situation where I would have to use like ton of different variables in one pipeline, then I would really think that is the pipeline the right tool that I'm using for these tasks, or should I use, for example, a notebook that gives me a lot more flexibility to write my own code and build my logic that way. Because with pipeline tool, I think the simple pipelines are the best because you don't really want to build complex logic here. But parameters and variables are a great addition to your toolbox when working with pipelines, since they allow you to add more dynamic logic there that is needed in some cases. In this lecture, we're going to be learning about expressions and dynamic content. We already covered dynamic content a bit in the previous lecture, but now we expand this concept more and focus on different functions that are available with pipeline expression language and how those can be used to build dynamic logic. Let's get started. Let's first cover a few key points about expressions. Firstly, expressions are used for adding dynamic logic to pipelines in Mux Fabric, and they are particularly useful for generating file paths, setting parameter values, and customizing outputs. They can be also used to validate data and handle errors dynamically. Expressions in pipelines start with @sign and are most commonly used using the expression builder. Also, expressions can be added into string values, but then the syntax is a bit different, since the expressions have to be started with the @sign and then the expression itself has to be wrapped in the curly brackets. Functions are a very important part of expressions, and usually expressions consists of one or more functions that add extra logic to the expression. Next, let's cover the different types of functions that are available when using expressions. Firstly, we have string functions that are meant for manipulating text values. These functions can be used to format, combine, or alter string data in various ways. One good example of a basic string function is the concat function that is meant for combining text pieces together. Another example of a string function is the replace function that could be used to replace part of the text value with some other text value. Next, we have date functions that are useful for creating datetime-related logic to pipelines. These functions could be used to format, extract, and compute dates and times. One of the most used date functions is the UTC-now function that returns the current UTC date time as a string value. Then we have other date functions like addDays that is meant for adding days to datetime values. Third, we have logical functions that allow adding some Boolean, meaning true or false logic to the pipeline. Example of logical functions are your basic logical operators like and, or, equals, greater, and so on. Then we have math functions that allow performing arithmetic calculations and mathematical operations. Some examples of these functions are add, subtract, multiply, round, max, and min functions that are quite self-explanatory what they do if you have done some basic math studies. Next, we have collection functions that are meant for manipulating arrays and objects. These functions are essential for handling complex data structures within pipelines. One example of these functions is the union function that can combine two arrays together. Another example could be the empty function that returns true if an array or object is empty and false if it is not. Lastly, we have conversion functions that allow converting values from another data type to another. One of the most basic of these functions is the string function that returns values that are given to it as strings. Then we have a bit more complex conversion functions like the XML function that allows converting JSON objects into XML. Next, let's cover a few very useful examples of function usage in pipelines. Let's start with concat function, that is one of the string functions that are meant for combining two or more strings together. Syntax for this function is concat, then opening bracket, and then text values in single quotes separated by commas, and then closing bracket. This function requires 2 or more strings as parameters, and then the return value or the output of the function is a combined string from those parameter strings. Next, let's go through a quick example how this concat function works. Let's start with 3 input strings that we want to give to our concat function. Our first string is file, and our second string is _1, and then our third string is .txt. Then we want to give this input string as parameter for our concat function and wrap them into single quotes and separated by commas. Also, it is good to remember that expressions begin with @. I have also done some color coding here that it would be easier to break down this expression into its different parts. After this function executes, we get our return value or output. That is just these 3 strings combined together. Next, let's go through one very commonly used date function, which is the UTC-now function. This function returns the current timestamp and it can take one parameter as input. But this parameter is optional and it can be used to format the output timestamp if developer so desires. The default timestamp returned by the function when the format is not specified is this ISO standard timestamp. Also, a good thing to note is that pipelines do not have date or datetime data types when talking about expressions and dynamic content. So that's why the output has to be a string data type. The syntax for this function is very easy if we do not provide any format as parameters, since it is an optional thing to do. When running this function without any formats, we get that timestamp in that ISO standard format. Now let's do another example, but now let's provide a format for the UTC-now function. This format is given to the function in string notation, so using single quotes and then representing different components of the time using this notation seen on the screen, where year is represented using 4 lowercase y letters and month using 2 capital M letters and so on. After running this function, our output is a timestamp that follows the format that was given it as a parameter. And from my color coding, you can see how these numbers map to the format that I used as an example here. Now let's do one more example where we combine these 2 functions together. We're going to use the concat function as our main function, but with a little twist, since the first input string is going to be a file underscore, but our second input string is not going to be a regular string, and we're going to use the UTC-now function with the format as our second input parameter. Then our third parameter is going to be .txt. Here we can see how we would be able to create the expression using these 2 functions together. Also, if it is not obvious, the execution order for these nested functions is always from the inside out, meaning that when the function runs, the UTC-now resolves first, and then the output of that function is used as a second input parameter for our concat function. Here we can see how does the return value or the output look when we would run this expression. Now I have this empty pipeline development canvas open here, and to this canvas let's just add one copy data. And with this copy data I'm going to copy this one CSV file from this Lakehouse source folder to this destination folder, but add some like expressions when evaluating the name when we copy that file. Meaning that when we copy that file we use expressions to add more things to the file name, so we're not going to keep it as movies.csv as it is in the source folder. So let's go to the pipeline and let's configure our source, and we are going to not need a connection since we're within the same workspace. Then we're selecting the Lakehouse we want to use and then the file section, and now we are able to navigate that Lakehouse to that source folder. It should open up fairly quickly here. Let's select the source folder and then we are going to select the file, and now we have hard-coded our source file, and we're using binary copy, so we're not doing any data transformation here this time. And then to the destination side, again, no connection needed here, and then we're selecting the Lakehouse here, and then we are using the file section, and now we can set the directory to be the destination folder here, so let's select that, but then for the file name, let's do some dynamic stuff there. So now the file name hasn't been defined, so we want to define that by using the expression language. So we can click this file name field here, and then we can see this add dynamic content pop up here, and now we can click this and start to add dynamic content here. And now I would like to build this kind of a dynamic content expression that would add a timestamp to that file name. We can firstly open up this function tab here, and here we have all the functions that are available in the pipeline. So we have quite a many different functions that we can use, and we're not going to go through all of these since most of these actually I probably have never used, but basically they are here if you need them for something. But now I'm going to use the concat function, but we can, for example, find the concat here, and here we can also see some information and documentation about the concat function, what is expected and what it does. But yeah, let's click this and it will create this concat function here. But now we already see that concat does not accept 0 arguments, so we need to add these parameters for this function. So we could, for example, add here first the movies, and then we could add underscore. And now we could use the UTC now function here to add that timestamp here. So let's select the UTC now function. Now it is added there, and then we could add another string there and add the file ending there. So now we are constructing a new name for our file. So basically we are combining movies underscore, and then we're adding that timestamp and then .csv. And now we can also evaluate the expression here and see how it would evaluate. So this is a pretty cool handy feature that we have here, and this is quite new feature that we can use to evaluate these expressions. And here we can see that we get this quite ugly and long timestamp there, and maybe that is something that we don't want to have here, because it would be less optimal to have these like dots and everything in the file name. So we can modify our expression and maybe add that format to our timestamp. So let's add that format here. So now we're specifying format for that UTC now function and getting that formatted timestamp. So let's evaluate the expression right now, and we can see now that we have this more compact timestamp here. And here we have that file name that would be created if we would run it right now when I evaluated that. Of course, it will be slightly different always because the time will go forward. But yeah, now we can click OK, and now we can validate our pipeline and see has it validated correctly. And now we can click run, and we can see that does our copy data work as expected. Now our copy data has executed, and we can check out the lake house. Did we have a new folder in this destination folder here, or new file I mean? But yeah, there is the file movies underscore the timestamp.csv. So we saw that it worked properly, and now we can go back to the pipeline. And here we can actually use this, especially the input here, to see what was the evaluation of that specific expression that we created. Of course, now since we have that expression evaluation feature always there, that's also handy. But here we can see that what was the evaluated file name when the pipeline ran. And there we can see that. And also, it is good to talk about the pipeline JSON and how that's handy when working with this dynamic content in general. So let's open up the View tab, and then we can see this edit JSON code, since the pipeline on the background is this JSON here. But basically, here we can see all the configuration that we have for the pipeline, and we can see what kind of values each field is expecting. For example, if we take a look at this retry field here that we have there, we can see that it is expecting to have an integer value. Also, this retry input intervals in seconds is also expecting to have this kind of an integer value. But then these secure output and secure inputs are expecting to have Boolean values. And then the timeout is expecting to have a string value. So when we open up copy data, those are basically these values that we are seeing here. So here we have this secure output and input that are Boolean values. There are basically these checkboxes. So if you have a checkbox in this UI, it is basically already a giveaway that it's probably expecting to have a Boolean value. And actually for these, we cannot add any dynamic content. And it seems that all of these are outside of the dynamic content scope. So those were quite bad examples. But for example, here in the pipeline source configuration, we can configure this delete files after completion, and this is expecting to have a Boolean value since it is a checkbox. And we can confirm it by checking out the pipeline JSON, and here we can see deleted files after completion, and we can see that false there. So this means that it is expecting to have a Boolean value. So, and how this will just work when you're defining the dynamic content, you would need to make sure that if you define some expression here, it needs to be evaluated to Boolean when the pipeline runs, because these different functions here will evaluate to different types of data types. For example, these string functions basically typically evaluate to strings. For example, this concat will always return a string. But then, for example, when we think about these logical functions, and some of these, for example, this equals function will evaluate to a Boolean value when it runs. For example, if you combine two numbers here, like for example is 1 equals 1, and it is, so the evaluation will be then Boolean that's returned from this expression. And basically there are also functions that then return integers, etc. So there are different options that can be used. But the pipeline JSON is a handy tool to check out what kind of value each field is expecting if it is not obvious from the UI. In this lecture, we're going to be learning about if condition that allows us to build some conditional logic to our pipelines that can be handy in some cases when we want to process data conditionally. Let's get started. First, we can imagine a situation where we have a data pipeline in Microsoft Fabric. In that pipeline, we have one activity followed by another activity. However, after our second activity, our pipeline's logical flow splits, and we have two more activities, activity 3 and activity 4. We don't want these activities to run at the same time, and we would like to run activity 3 on Sundays and activity 4 every other day than Sunday. How could we achieve this in a data pipeline? Of course, we can wrap these activities to an if condition activity, and that has the logic to run the activity 3 on Sundays and run activity 4 every other day than Sundays. We will come back to the same example in just a moment, but before that, let's digest how if condition activity works in a bit more detail. Here we can see how does the if condition activity look in the data pipeline UI. First, for the if condition, we would have to define a condition expression using the pipeline's expression language. The only limitation for this expression is that the output of the expression has to be a Boolean value, meaning that it has to resolve to true or false. Next, we have the two branches in our if condition. There is one branch for the true value and then one branch for the false value. And based on our expression that resolves to true or false, the pipeline will decide which branch to use. Inside one of those branches, we can then add actions/activities that we want to perform. When our if condition executes, first our expression is evaluated whether it is true or false. If it is true, then our if condition will execute all the activities in the true branch, and if it's false, then it will execute all the activities in the false branch. Next, let's cover more in detail how expression evaluation works and how it is decided which branch to use. Our pipeline logic for this imaginary situation is that every Sunday we want to fetch all the 30 tables from the source. Otherwise, we will just copy 5 tables that are needed daily. Our run schedule for this pipeline is every day at 5 a.m. UTC time. Then we have our if condition, and in that if condition we have our two branches. In our true branch we have the logic to copy all the 30 tables from the source, and then in our false branch we have the logic to copy only those 5 tables that are needed daily. Now we would need to build an expression that would evaluate the true when it is Sunday and false when it is not Sunday. Here we have that expression that would handle this logic for us. Basically, we would need to have 3 functions in our expression. The innermost function we have is the UTC-now function that will resolve the current timestamp into UTC time. Then we have wrapped that function to the day of the week function that will take the timestamp from our UTC-now function and return a number from 0 to 6 based on which day of the week it is, based on our timestamp. 0 means Sunday, 1 means Monday, and 2 means Tuesday, and so on. Then the outermost function we have is the equals function that will then compare the results from our day of the week function to a 0 and then evaluate to true or false based on the outcome of the day of the week function. But now let's do an imaginary run for our imaginary pipeline for a June 2nd, 2024, which happens to be Sunday. And let's see how our expression would resolve step by step in this situation. First, when we would run our expression, the UTC now would resolve to the current timestamp since it is the innermost function in our expression. Second, our day of the week function would resolve using the timestamp that came from our UTC now function. And since our pipeline is running on Sunday, it will resolve to 0. Then lastly, our equals function compares does 0 equals 0, and it does, so it will then resolve to true. This means that our if condition will then run activities in our true branch, and in the context of this example, copy those 30 tables from our source. Next, let's run this same pipeline again, but now it is running on the following day, which is June 3rd, 2024. This means that now our expression will resolve to false, since our day of the week will return 1 for one day, and our equals will then compare 0 to 1, which obviously is not true, meaning false. This will then guide our execution logic to the false branch, which will then only copy those 5 tables from the source. Next, let's go to Fabric and check out the if condition there. Here I have a blank pipeline development canvas open, and we can open up the Activities tab, and here we can find this if condition activity. And here we can see those 2 branches that we have in this activity. Let's define one activity for each branch. I will just use these simple wait activities, and I will name this based on the branch so that we can see which activity will run when we run this pipeline. So let's name this false. And now we have those activities. And by the way, we can add to these branches more activities than just one. So basically we can build a bunch of logic to these activities if we want. But let's keep this example simple. And now we would have to define this expression for our if condition. That can be found when we click this if condition activity, and we have this activities tab here, and here we would define that expression. And this will now expect to have a Boolean value. So here is the expression of if condition activity. The value must evaluate to true or false. So we would have to use some function or some logic that would evaluate to true or false. Maybe we can add one parameter to this pipeline and say that this is like param1, and we can add it to be int value, and then we can pass some value here and then compare that in that if logic to determine to which branch we are going. So let's open up the if condition here, and then let's open up the pipeline expression builder, and maybe we would now find the equals function here. So let's select the equals function, and for the equals function we are going to give, like, for example, that 0 value, and then we are going to use the parameter as the first argument. So now we are comparing the parameter value to 0. And if it's 0, then this equals function will return true because 0 equals 0. And if it's something else, then it will return false. And now we can evaluate the expression and see how it works. For example, if I put here 1 and I will evaluate, we can see what is the result. It's false. And then when we put here 0, then it should evaluate to true. And now, so that our expression is working as expected. So we can close this. And now we can go to the Home tab, and then we can click Run, and then we're going to click Save and Run. And now we are going to provide then value for our parameter. Let's add there, for example, 3. And if everything goes as planned, we should end up to the false branch, because basically 3 doesn't equal 0. So we should end up there. So let's refresh this, and we can see that our false wait activity ran there because I name it false, and we can see that it ran, and we never ran that true wait activity there, because the if condition activity will only run the activities on that branch that it went to, and it won't run any of the activities from that other branch. But basically this is just the basics how to use this if condition activity, and the key thing to remember that this expression here has to always evaluate the Boolean. So you have to select the functions and the logic that will give Boolean as result. Of course you could nest a bunch of different functions, but the outermost function has to always end up to a Boolean value, so this if condition would then work. But yeah, let's cancel this, and this is basically how you would be able to build this conditional logic for your pipelines using if condition. In this lecture, we're going to be learning about scheduling and monitoring our pipelines. We learn about different scheduling cycles, monitoring pipelines via Monitoring Hub, and locating errors in failed pipeline runs. Let's get started. So here I have this data pipeline with only this simple wait activity here. And now let's talk about scheduling pipelines. So let's open up this schedule here, and here we can click Add Schedule. And here we can start to configure a schedule for our pipeline. And we have quite a bit options here what we can do. So we can select to schedule this by the minute, by the hour, by the day, by the week, by the month. And here if we use the minute one, we can schedule the minute interval when we want this pipeline to run. And when we change these options, then these change a bit. For example, with daily one, we can select the time of the day and add multiple times per day when we want this to run. And then when we change to weekly, we get even more options. So we can select the days when we want this to run. And then with monthly, we can also specify a bit more options. So we can specify the interval and then the day of the month or a specific weekday when we want this to run. So we got quite a bit of flexibility here that we can do. Typically, I use this daily schedule, or I think this is one of the most used schedules when talking about these like production-ready pipelines, because typically people run their pipelines in this batch manner. For example, once a night, the data is refreshed from the source systems to the data platform, and then you want to have this daily schedule and select the time of the day when it runs. And then we can configure the start and date times, so when the schedule is active. So only in this specific time window it is active. Typically the best practice for the date, the end date and time is to set it to the far to the future so that it won't expire. So because you don't want to end up to a situation where you just notice that your data pipelines are no longer running because you didn't set the end date and type enough far to the future. Of course, it would be nice if you would have like some kind of like that it's basically running until you stop it, but here we don't have that option. Or we can actually configure it with another way that I'll show it to you quickly or soon. But here we can also select the time zone to which we want our schedule to run, and actually the correct time zone for me would be the Helsinki time there. Of course the Athens time is pretty much the same, but yeah, this would be the correct one for me. And now if I would save this schedule, we would have it here. And here we can actually toggle this schedule on or off, but basically now it would be running and we can see the schedule information here. And we can, by the way, add here more schedules, so we don't have to just rely on one schedule per pipeline. So basically here it says that we can add 20 schedules per pipeline if we want, but for now I don't want to add more schedules to this pipeline. And actually I don't want to add any schedules to this pipeline since I don't want to schedule this, so let's delete that so we don't have any schedules. Before we go to the Monitoring Hub and talk more about monitoring there, I want to show you that we also have this kind of a view run history button here in the pipeline where we can see those past run executions for it. And there we would be able to dig into logs here and see what happened during that execution. And here we would be able to investigate if there were some errors, for example. But the same information can be seen in the Monitoring Hub. But before that, I can show that I have these two example pipelines in this workspace that do these copy activities. And next, we are going to take a look at them in the Monitoring Hub. And here we can see these scheduled example pipelines that are running basically once in a while. And here we can see how those have went. So we have also failed pipelines here. But here in the Monitoring Hub, we are able to see all the pipelines that we have access. So we are able to use these filter features here and, for example, select the workspace in which those pipelines are running if we want to filter down this list, and also select some item types, because we can also see some other types than pipelines here, because many other objects and items in Fabric can be run as well, and we would also see them in this same Monitoring Hub. So this is like a Fabric-wide Monitoring Hub, but typically you want to filter down these by the failed pipeline, because typically in the Monitoring Hub you're looking for failed pipelines. So using this failed filter would be helpful here. And here we can see that we have some failures here. And now if we would dig into those, we can click the pipeline name here and we would get more information about that execution. And here we can see that we have a copy activity in this pipeline and that copy activity has failed. And here we can see that the copy activity failed if we click the activity name, and there is the information that it failed and also information what it did before it failed. But the most important information here is here in this fail icon, and there we can see this little error message there. And this will open up the error message and tell us what happened. And this error message can seem a bit scary first, but these are actually quite easy to read when you get hang of them. Of course, it depends on the source what kind of error message you will get. But basically, if we check the error code here, it says user error file not found, and it says lakehouse operation failed for operation returned an invalid status code not found. So basically this indicates that the file was not found. So path not found message here. So we tried to find this file/sources/animals.csv, and if we go to the lakehouse that is being used as a source for this, we can see that there is no animals files in this source folder, so it cannot find the file and thus it is failing. And by the way, in this error message, we are getting this ID here that is basically your lakehouse ID. And from this lakehouse ID, we can confirm which lakehouse this is. So basically, I can go to this lakehouse and this is the same ID we can see here. So this is the internal ID for the lakehouse. So we have that 85.6 and we have that same 85.6 there. So it doesn't use the lakehouse name. Maybe it would be a bit more helpful if the lakehouse name was there. But this is how you can open up these pipeline logs and try to figure out what's going wrong with your specific pipeline. Also, from the monitoring hub, we would be able to rerun these pipelines. For example, we have this retry button here, and we would try to retry the pipeline. So the Fabric would try to run that pipeline again, but I don't see any point to retry this pipeline now since the problem is that we don't have that file and it would just fail. And now we can clean this filter and then we can see the succeeded pipeline runs that we have here. And we are also able to rerun those. And also we are able to see some details about the pipeline run here and see some basic information about those. But yeah, this monitoring hub is a convenient way of looking at these pipelines. And also we can add even more columns here. For example, we can add capacity here so that we can see which capacity was used to run these pipelines. And it is my trial capacity that is used to run them. And also there are other options that could be helpful in some monitoring scenario, but I'm not going to dig too deep into these now. But basically now you should have a basic idea how the monitoring hub works in the pipeline context and how you can use it to monitor your pipeline runs. And this way you can also find what went wrong with your pipelines and try to identify errors with them. In this lecture, we're going to be learning about ForEach Activity that allows us to add some very powerful iterative logic to our pipelines. ForEach Activity is also one of the most important pieces of metadata-driven pipelines that we're also going to cover later in this course. But now let's learn about ForEach. First, let's imagine a situation that we have a CSV file in our lakehouse and we would like to copy this file to a lakehouse table. In Fabric, we have multiple ways of achieving this goal, but using data pipelines is one of the easiest and best ways of achieving this goal. And building this kind of pipeline is a really simple task, and one copy activity in a pipeline should be enough to handle this case. But what if instead of one file, we have 20 files that we would like to copy to 20 different tables? This would mean that we would need to add 20 copy activities and configure them separately. That is already quite time consuming and makes our pipeline a lot more complex. This is the stage when ForEach Activity steps into picture, since we can just wrap the copy activity to a ForEach activity and iterate over it 20 times, thus reducing the number of activities from 20 to just 2, and those are ForEach and inside that ForEach the copy data activity. Now let's take a closer look at how ForEach activity works, and here we can see how does the activity look in the pipeline UI. ForEach is an activity that takes in an array of items. For example, a simple array of string items could just contain 2 strings. These arrays can be also way more complex, like arrays of objects with multiple layers that will allow us to build very powerful configuration-based logic to pipelines. ForEach activity is an activity that wraps other activities, meaning activities can be added inside the ForEach activity with some limitations. In this sense, ForEach resembles quite a lot of the if condition activity. When the ForEach activity executes, it will run all the activities for every item in the list. Now let's go through how this iterative logic works. Here we have our ForEach activity. Inside that activity, we have another activity that we would like to execute as part of our ForEach logic. Then we have our array of items. In this case, we have 3 items that we are going to pass down to our ForEach activity. The values in this array could be any data type that are supported in data pipelines. So basically, we could have an array of strings or maybe an array of integers, or in some cases, we could even have an array of objects that we could pass down to the ForEach activity. In this case, I'm just representing the items as item 1, item 2, and item 3 to simplify this example. Inside the activities in the ForEach activity, we are going to reference these items with the reference @item. This will fetch the current item in the loop from the list of items that we are running in the ForEach activity. So, during the first iteration of our ForEach activity, this item reference will fetch item 1 from our array and use that value in our activities. After we have executed all the activities in the ForEach activity, we start over. Now we again have the item reference, but since this is the iteration number 2, we are going to now fetch the item 2 from our list using the @item reference. After our second iteration is done, we have the third iteration, and then we are going to use the @item reference and fetch the item 3 from our list. This is the last iteration, so after we are done executing all the activities for this iteration, we are ready to continue forward from the ForEach activity. Next, let's digest this ForEach item reference a bit more and use a bit more complex array that has 2 objects inside it as an example. In those objects, we have 2 properties, src file and dst table. Then we can imagine that we're passing this array to our ForEach loop, in which we would then refer these objects in dynamic content of our activities. If we would like to refer those 2 objects, we would use the @item reference. In the first iteration of our ForEach, that @item would be replaced with our first object, and then in the second iteration, it would be replaced with our second object, and so on if we would have more objects in our array. Then what if we would like to refer these properties inside of our objects? For referencing src file property, we would use .src file after our @item, which would then get the value stored in the src file. That would be file 1 for the first iteration and file 2 in the second iteration. Same logic applies to our second property dst table, and it would be referred by using .dst table after our @item. Next, let's go to Fabric and do a demo to really understand what this ForEach is all about. So, here I have this blank pipeline canvas open, and in this canvas I will just add the ForEach activity. And now let's open up the settings tab to learn more about the settings that we can configure for the ForEach activity. First we can see this sequential setting, and now when this is not tabbed, basically this means that the ForEach iterations could run in parallel, meaning that we could have multiple different iterations going on at the same time. But if I would tap this, this would mean that ForEach would run in sequential manner, which means that the previous iteration has to be completed before the next iteration starts. But if we don't tap this, we can see that we can define this batch count for our ForEach activity. And with this, we are able to control how many parallel executions we have happening at the same time. For example, in some cases, if you are using ForEach to copy data from some source system, you might want to define a batch count there so that it won't overwhelm the source system with so many concurrent queries if you have a ton of copy activities that are happening in the ForEach loop. But basically, basically these are two good settings that you should be aware of when using ForEach, and you can do some minor configuration for the iterative logic. Of course, when not running this in the sequential mode, the ForEach will basically run faster because there will be some parallel execution, and then you use the batch count to control that parallel execution a bit. And then we have this item setting here, and this is basically expecting to have an array. And to this pipeline, let's just add one activity inside this ForEach, and that activity is actually going to be a wait activity. And here we have this simple wait activity that we would run in the ForEach loop. And now to this items field, we would need to provide an array or list of like something. And here I have an example of this kind of an array of integers. So here I have three integers, 1, 2, and 3. And this I'm going to pass down to this items field. And one of the most convenient way of passing this kind of information is to actually use pipeline parameters. Let's change the data type to an array, and then we are going to name that wait time array, and then we are going to copy that specific array to the default value of this array so that we don't need to define it every time the pipeline executes. But now we are going to use this parameter as the input for our ForEach so that the ForEach will basically iterate over this array that we have defined here. So let's go here, and then we are going to use the dynamic content, and here we can see the wait time array, and then we are going to use that. And now we can validate our pipeline and see that it is valid, and now we can click run and it will run our pipeline. And now basically when we haven't defined that sequential setting, all of the wait activities should run at the same time, since we haven't defined the batch count either, and we have only 3 iterations that we would go through, and we can already see that those are now running and they started at the same time and all of them completed. Next, we could modify this pipeline a bit and open up this wait activity and actually utilize the dynamic content in that array as part of the logic here. So here we have these items in that array, this 1, 2, and 3. And remember, we can use this item reference to reference these different numbers here. So basically, if we would like to refer these things, we could use the @item reference dynamically in this wait activity that is inside the ForEach loop. And we can, for example, use this wait time in seconds and dynamically set its value as the current item in the loop. So this means that when our ForEach will now run in the first iteration, it will get this number 1 value, so it will wait 1 second, and then in the second iteration it will get this number 2 value, which means that it will then wait 2 seconds, and for the third iteration it will get this number 3 there, and it will wait 3 seconds. So let's run our pipeline and let's validate that that will actually happen. So let's click run, and again we are using the same array that I have as a default value there. So let's click OK. And now the run should start. And now the run has succeeded, and we can see that now we have some different durations for these wait activities. And here in the input, we can see what wait time was used for each wait activity. For example, for this wait activity, we passed down the number 2, which means that this was the second iteration. And then here in the wait activity, we had 1, which means that this was the wait for the first iteration, and then this was the wait for the third iteration, since we have the number 3 there. So now with that dynamic reference, we were able to change the behavior of the wait activity based on the input array that we passed down to this ForEach. And now let's do another example of the ForEach activity. And now let's do a bit more complex example and add ForEach activity to this pipeline, and then open up this lakehouse where I have these 2 CSV files that are pretty standard CSV files with just a header and few rows of data. And now I would like to copy the contents of these 2 CSV files to 2 different tables in this lakehouse. And for that, I'm going to use this more complex array where I actually have 2 objects inside of my array. So I have this first object that basically describes the configuration for copying this animals file. And then I have this second object here that contains the information for copying that movies file. So basically this just tells what is the source file and what is the destination table. And now let's build a pipeline that will utilize this as a parameter and does that copy. So let's go to that pipeline. And here in the pipeline, we want to add copy data activity to this ForEach. And as a parameter, we want to have that file array file array as a parameter, and we're going to set it as a data type array. And then I'm going to copy contents of this array as a default value for this parameter. So now it is copied there. It is a bit hard to see there, but the contents are now there. So we have an array of objects that we are going to use there. And now let's configure our ForEach to use that array as an input. So here we have that file array, and now it is being used as an input for our ForEach. And now let's configure the copy data activity to use that dynamic content from our array. So let's open up the copy data activity, and now let's configure the source first. And we don't need to use the connection since we have the lakehouse in the same workspace. And here we are going to use the file section. And now we could first navigate to the folder that we have here to make this configuration maybe a bit more simpler. So let's wait that lakehouse to open up. And there we have the folder, and in that folder we can select one of the files there, for example the animals files, and then we are going to change the file format to delimited text. And then we can check the preview data. Does the data look good, or do we need to touch the CSV settings there? And it does look good, so it should have been configured correctly. But now for the source file, I don't want to hard code the file here because I want to dynamically use the values from these arrays. So remember that when we are referencing these objects, we would use that add item reference, and then when we want to fetch individual properties inside these items, we would specify those with object notation. For example, when we want to fetch this src file property, we would use add item.src file. So let's do that, and let's remove this hard-coded value there. And then we are going to use that add item, and then we're going to use .src file. And this will basically then fetch this src file. So basically add item is this, and then we have the src file there. But yeah, now that has been configured. And next we want to configure our destination side. And here we're again going to select the non-data stores, and then we are going to select the pipeline intermediate lakehouse. And then we are going to now select the table section and define the table manually. We can use the DBO schema in this case. And now we are going to dynamically set the table name there. And with here, I'm going to now need that destination table property. So we are again going to use that add item reference, and then we are going to select the destination table from that array. And then we can click OK. And now the copy data should have been configured correctly. And of course, we can just change the table action to overwrite so that it will overwrite the data every time this pipeline runs. But now we can try to validate the pipeline and see that everything has been configured correctly. And now we can hit run and see, does it work as intended? So let's click save and run, and then we would need to provide a value for our parameter, but since the default value is already the array we want to iterate over, we can go with that, and now our pipeline will start to run. And now our pipeline run has succeeded, and we can see that we successfully executed 2 copy data activities since we had those 2 items in our array. And probably we were able to fetch the properties correctly. So let's check out our lakehouse, and do we have there 2 tables under this DBO section. And there we have the animals table, and let's just quickly preview the data to see, does it look good? And it does look good, and then we can check out our movies table and see what does the data look like in that table. And it also looks good. So basically we were able to copy the contents of both of these files successfully to both of these tables by using iterative logic in our pipeline and using dynamic content in this copy data activity to do dynamically those copies from those files to those tables. In this lecture, we are going to be learning about Lookup Activity that allows us to fetch data from some data store so it can be then used in the pipeline execution flow as dynamic content. Along with the ForEach that we covered in the previous lecture, Lookup is one of the typical pieces of Metadata-Driven Pipelines that we are going to cover later in this course. But now let's learn about Lookup Activity. Let's imagine a situation where we have a Fabric pipeline. In that pipeline, we have a copy activity. We also have a lakehouse, and in that lakehouse, we have a configuration table. We would like to use the contents of this configuration table to instruct our copy data activity to copy some data. How would we do this? Of course, we can use the lookup activity in the data pipeline and fetch the contents of that configuration table and have them available in our pipeline for our copy activity to use. Now let's take a closer look at how lookup activity works in a data pipeline. The lookup activity can retrieve contents from a dataset that is sitting in some data store. It has two options: to retrieve the first row from the dataset or retrieve all the rows from the dataset. However, there are limitations on how much data the lookup activity can return: a maximum of 5,000 rows and maximum size of 4 megabytes. After the lookup activity runs, the contents of its output can be used in the following activities as dynamic content. Let's take a look at how inputs and outputs work with the lookup activity. Let's have a lakehouse with a configuration table that has two columns: source file and destination table. On the first row, the source file is currency.csv and the destination table is currency. On the second row, the source file is money.csv and the destination table is money. We would like to use these values in our data pipeline to copy the contents of the currency.csv to currency table in the lakehouse and money.csv to money table in the lakehouse. This table will be the input for our lookup activity. Let's configure our lookup activity to only retrieve the first row. When our lookup activity runs, the output will be the first row of this table, meaning we only get the source file and destination table of the first row, currency.csv and currency. These two values are wrapped in an object called first row. Next, let's run our lookup activity again, but this time we will uncheck the first row only setting. Our lookup activity runs and we can see a different output this time. We get the count of how many rows were retrieved and the value array containing all the rows that were retrieved. In this case, we have two rows, so we get both the currency and money configurations from the configuration table. Now this output of the lookup activity would be then available to use in the following activities in our data pipeline. For example, we could pass this value array to a ForEach loop and start to iterate it and do actions based on the configuration data. Next, let's go to Fabric and do some demos about the lookup activity to really understand what it is all about. Now we're in Fabric and I have this lookup demo source folder here, and in this folder I have this one txt file. And now I would like to copy this txt file to this lookup demo destination that is currently empty. And I'm not actually going to build a pipeline where I hard-code the information of this file and its location. Instead, I have this lookup demo config folder, and in this folder I have this file config. And this file config will tell the information: what is the file name, what is the source folder, and what is the destination folder. And now I could use a lookup activity to look up this information and then pass this information dynamically to copy data activity so that it will dynamically copy based on this information provided in this configuration file. So let's start to build that pipeline. And now to this pipeline, let's add a lookup activity and let's configure the lookup activity to retrieve the information from that configuration file that we had there. So we had that in the directory called lookup demo config, and the file name was file config.json. So now we're pointing that lookup activity to this configuration file that we have here. And we of course need to change the file format to JSON, and we can quickly press the preview data to see that we are able to read that data correctly, and we can retrieve that information there. And now we could try to run this lookup activity with this first row option on, and we can see what kind of output it will yield. And now the pipeline has succeeded, and we can check out the outputs of this lookup activity to see what kind of content we would have there. And there we can see when we use that first row option, we now have this information from the configuration file wrapped to this object called first row. But since in that configuration file that we have here, we only basically have this first row, so the first row option doesn't really change the behavior in this case that much, so that we can go with that. But yeah, let's go there. And if we wouldn't use this first row option, we would get there more information, and we can check out quickly how the output will look if we don't use the first row option. And now let's run this and let's see what is the change there. And again, our pipeline has succeeded, and we can check out the output this time. And now we can see that we have this count there that tells how many rows were retrieved, and then we have this value array where that same data is. But yeah, this time let's use that first row only option when we move forward to the copy data activity, because in this case I think it's more straightforward. So let's add that copy data activity there, and then let's configure this copy data activity to copy that file dynamically to that destination folder. So we're going to use the file section, and then we are going to do binary copy. So we are just moving that file as a binary block. And now to this dynamic content, we can utilize the output of the lookup activity as dynamic content, since this lookup activity is executed before this copy data activity, so that output is available here. Of course, if this logical execution flow would be different, we wouldn't be able to use this lookup activity information as the dynamic content here if it would run after the copy data activity. But since it runs before the copy data activity, we have that information available here. So we are going to select this lookup one first row, and from this first row we want to use the object notation and retrieve that source folder. And now this directory path should be configured correctly, and then to the file name we again want to use the first row, but this time we are going to get the file name there, and then we are going to click OK. And now the source side should be configured correctly, and we can move to the destination side and again select that lakehouse, and then we are going to use the file section. And this time I think we are only going to specify the directory, since when we don't specify the file name, it will actually use the same file name as it was in the source. So here again, we are going to use the object notation, but this time we're going to use the destination folder. And now this should have been configured correctly, and we can click run, and let's see what happens when we run this, and are we able to copy that file to that destination folder that is the lookup demo destination in this case. And now our pipeline has executed, and we can check out the logs of the copy data and see that one file was read and one file was written, and we can go and check out our lakehouse, and now we should have that file here in our destination folder, and there it is. So super quickly to summarize what we did there, we used the lookup activity to fetch the contents of the configuration file to this pipeline so that we are able to use this output here as dynamic content in the following activities. And then we used that lookup activity output here in the copy data activity to instruct it dynamically to copy that file based on the lookup information. Next, let's do another quick example of using the lookup activity, and this time let's use this wait times CSV where we have the header and 2 rows of data, or basically we have there just 1 and 2 as wait times. And now let's go to this pipeline, and here I have a blank pipeline canvas, and to this canvas let's add a lookup activity, and then we are again going to configure that to use the lakehouse, and this time we don't want to use the first row option, since I want to fetch the entire contents of that specific file from there. And now let's find that file here in our lakehouse using this UI here, and here we should have that waittimes.csv. Yes, we have, and we have the delimited text already selected here as a file format, and we can preview the data and see how does it look. And this looks good, so we are able to read that data correctly with our lookup activity. And now we could run the lookup activity and see what kind of output it will yield when we are not using the first row option, since in this case we don't want to use that, since I want to fetch the entire contents of that file to this pipeline and use that as part of the dynamic logic here. Now the pipeline run has succeeded, and we can check out the output here, and we can now see that we have that count, how many rows were retrieved, and then we have information of those wait times from that CSV file. So basically we have the CSV information now here in this kind of a JSON format, or actually in this array there. And now, since we have an array here, we can actually use this value array as an input to a for each loop and loop through these two rows. So basically we would have two iterations in that for each when we use this array as an input. So let's add a for each after this lookup activity, and then we are going to refer the output of the lookup activity in these items here. So here we have already this value array predefined here that we can click, and this will then define that expression that is needed to fetch that value array using this object notation here. So we can click OK, and then we can add a wait activity to this loop, and we can actually refer to the item that we are looping over in this wait time seconds dynamically. So here we can use the for each item, and then we are going to use the wait time. Was it called here? Yes, it is called a wait time, and we can use that wait time there. So using the object notation, we can fetch that wait time from that item. And now we can click OK. So now when we're passing this array here as an input to that for each, we are then also using this wait time information here dynamically in that wait activity inside that loop. But yeah, let's run this and let's see that everything works as planned. Let's first validate our pipeline to see that there are no authoring errors, and then we can click run and see that we get some different wait times to that wait activity when this iterates over it. And now the pipeline has succeeded, so the lookup ran there first, and we got the output that we already took a look at, and then we used this value array here as an input to our for each. So basically we had two items in that array, and then from those items we also fetched that wait time as dynamic information to the wait activity. So these wait activities should have different inputs here. So for this it was 2, so this was the wait activity that ran based on the information on the second row of that CSV file, and then we had this another wait activity that had wait time seconds 1, since this ran based on the information that was on this first real data row here. And also I want to highlight that lookup activity is not only for files, and we can use it to fetch information from delta tables and database tables. So it is a very versatile activity. Basically we can configure here different data sources and use this to fetch data from there, and then use that data as part of our pipeline as a dynamic logic. In this lecture, we're going to be learning about Get Metadata Activity that allows us to fetch all kinds of metadata information about files, folders, database objects, and so on, so that it can be then used as dynamic content in our pipelines. Get Metadata Activity can be a really handy tool in your arsenal when dealing with a bit more complex cases. But now let's learn about this handy activity. Let's imagine a situation where we have a lakehouse. In that lakehouse, we have a CSV file, then we have a Fabric data pipeline. In that pipeline, we have a copy activity that would copy the contents of this CSV file. However, we have wrapped this copy activity in an if condition, and we would like to only run this copy activity if the CSV file has been modified during the past 24 hours. How would we do this? Of course, we can use the Get Metadata activity in the pipeline to fetch the last modified timestamp of the CSV file, and then have the logic in our if condition to only run the copy activity if the CSV file has been modified in the last 24 hours. Now let's digest this activity in a bit more detail. This is an activity that retrieves some metadata information about some data object like file, folder, or database table or view. There are several different types of metadata that are currently supported depending on the source of that object. The maximum amount of output for this activity is 4 megabytes. The output of this activity can be used in the following activities as dynamic content. This activity is somewhat similar to the lookup activity, but the main difference here is that get metadata is for fetching metadata and lookup is for fetching actual data. Now let's take a look at a couple of these options and what kind of outputs they would yield in pipelines. Let's have a lakehouse. In that lakehouse, let's have a CSV file and call that file1.csv. Then we are going to have a get metadata activity in our pipeline. First, let's set the option of get metadata activity to last modified. Now when our get metadata activity runs, we can see that it will output the last modified timestamp of the file. Next, let's change our get metadata activity option to exist and run our get metadata activity again. Now we can see that our return value is a Boolean value, and it is now true since our file is there and exists. If our file didn't exist, get metadata activity wouldn't throw an error but would return false. Lastly, let's set the option to structure and see what kind of output our get metadata activity now yields when it runs. We can see that after it runs, we get a structure array in the output, and it has all the columns and their data types that we have in the CSV file. We can see that we have a column name and the type of that is string. Then we have a column called type and the type of that is string. And then we have a column called location and the type of that is string as well, since in the CSV file everything is basically string there. Like with the lookup activity, the outputs of the get metadata activity would be now available to be used in the following activities as input and dynamic content. This would allow us to build some extra logic into our pipelines based on the get metadata activity's outputs. Get metadata outputs that we covered on the previous slides are only few of many possible outputs that we can use. On this slide, you can see the entire list of different outputs that get metadata can fetch depending on the source, since some of these are only applicable to files and some to folders, and some of these can be used with database tables. You can pause the video and go through this if you want, but in my opinion, size, created, last modified, exist, and child items are the most used out of these. Next, let's go to Fabric and do some demos with the get metadata activity there. Here in my lakehouse, I have a bunch of files and tables that are left over from previous demos that I have done. But yeah, we can use these as inputs for our get metadata activity to demo some of the different functionalities that we have in that activity. So let's go to the pipeline and then let's add get metadata activity to this pipeline. And then we have to configure the connection, and I'm going to connect it to the lakehouse that I just showed to you. And we can first start from the file section, and we can actually point this get metadata activity to, for example, to one file and check what kind of metadata we can extract from, for example, from a file. So, for example, we can use this ForEach demo source here, and here we should have, for example, this movie CSV file. And then we can use this filed list here to add those metadata arguments that we would like to fetch. And here in the arguments list, we can see all the metadata options that are available when we are pointing this file path to a specific file and we are using file format as binary. But one thing to note here is that this field will actually changed based on these configurations. For example, if we remove the file here and we don't have that, we should have another option, that is this child items option. This means that we would basically able to fetch information what is inside of this folder when we don't point this to a file. But that is one of the things that changed when I used only the folder here and not the file. But if we add file back here, we can see that the child items is no longer available, and also this file format will also impact what kind of metadata options we have available there. For example, if I change this to delimited text, we can see that now we have, for example, a column count there, and then we should have, for example, a structure there, which will able to extract the structure of the CSV file, meaning the columns that we have there. And also it is good to know that we are not limited to one argument per get metadata activity, and we can actually add multiples here. So if we keep this as a delimited text and check with the preview that this is reading the data correctly, yes it is, we can start to add these metadata arguments that we want to fetch from that file. For example, we can fetch the exist information, meaning that we check that does that file really exist. Then we can fetch, for example, the structured, and maybe we can also fetch the column count there. Maybe let's add a few more here that are supported. We can, for example, fetch the item type, and then maybe we also fetch the last modified timestamp. Now we have quite many metadata arguments there, and now we can try to run our pipeline and see what kind of output this get metadata activity will now yield. So let's validate our pipeline. Our pipeline is valid, and then we can hit run and see the outputs of the get metadata activity. And now our pipeline has succeeded, and we can check out the outputs of the get metadata activity. And here we can see that it returns these different outputs, and these are all metadata about that file. For example, we have this exist information that says true, of course, because our file exists. And then we have the item type that is basically file. This could be also folder if we point this to a folder and not file. And then we have this last modified timestamp when this file was modified, and then we also have the structure in this array for the file, and then we have the column count, and also the execution duration is also given always as a default. And now let's change this get metadata activity to fetch information about a folder. So let's remove these arguments here, and then let's change it back to binary, and now let's add an argument, and let's add their child items so we can see what kind of output it will yield when we fetch that child item information about this folder. So let's again run our pipeline and let's see what is the output now. And now the pipeline has succeeded, and let's check out the output now. And here we can see that we get this child items array when we use this option. This means that we get the information what kind of files are sitting in that folder and what are their types, because also we could have nested folders there, so it would be possible that we have folders also in this specific folder or underneath. But basically we fetched information what files are sitting in this folder. And now we could actually use this information, for example, in a following ForEach activity and pass this information there and process these files dynamically. So this would be very helpful in cases where you don't know what type of files are landing to some folder, and then you could use get metadata activity to first extract that information, and then you could process those files using ForEach to, for example, Lakehouse Delta tables or whatever. Also, it is good to know that the get metadata is not only limited to files, and we can of course use it for tables, and we can, for example, select a table here, and we would be also able to fetch some metadata out of the table as well. And it also supports some database sources, so you can use it for Lakehouse tables, database tables, and those have some metadata that you are able to extract from those. So let's see what are the arguments here. So we can get the column count, and we can get the exist, and we can get the structure. So let's add, for example, all of these there so we can see what kind of output it will yield. But now we can run it and check out the output soon. And now the pipeline is done, and let's check out the output. So with those Delta tables or Lakehouse tables, we get also a lot more information about columns, since they are more rich in metadata basically compared to the CSV tables, because with CSV we don't have that much information tied to the file because it's basically a text file. But here we can see other properties than just the name and the data type. And also here we have that exist information and also the column count as well. And now when we have this metadata information here in the pipeline execution flow, we would be able to use these in the following activities. For example, using this exist value here, for example, in an if condition that is happening after this get metadata activity. So if we go to the if condition expression, we, for example, have the get metadata output exist information, and then we would be able to do this true or false logic based on that information that was fetched with the get metadata activity. In this case, this is the information, does the Delta table exist in the Lakehouse or not, and then we could do actions based on that information. In this lecture, we're going to be learning about metadata-driven pipelines that allow us to really unlock the full potential of pipelines for scalable data solutions. This lecture really builds on top of all the concepts that we have covered until this point, and you should be now already familiar with especially ForEach and Lookup that are the most important building blocks of metadata-driven pipelines. So let's get started. So, what exactly are metadata-driven pipelines? Well, to explain them simply, metadata-driven pipelines uses some type of configuration data, meaning metadata stored, for example, in tables, files, or parameters to determine what data to process, where to read data from, where to write data to, how to process the data, when and whether to run specific steps. The core idea there is that the pipeline itself will stay static, but it has been developed in a dynamic way that we are able to use metadata to change what happens when the specific pipeline executes. Metadata used for the pipeline logic is often stored in control tables, which in Fabric context could be in Lakehouse or Warehouse, or then it could be stored in files like CSV or in my personal favorite JSON files. Or in some cases metadata could be stored in pipeline parameters as well. There are also other options like creating this metadata dynamically from source systems information tables, to give one example, but those cases are a bit rarer. Here we can see a simple example how this kind of metadata could look in a table. In this table we have instructions for the source folder, source file, and then we have instructions for destination schema and table. In some cases metadata configurations could be as simple as this, but when we start to talk about full metadata-driven frameworks, these configurations get way more complex, but the basic ideology stays the same. The most typical variation of the metadata-driven pipeline looks like this, and it is operated by two main activities that are the lookup and ForEach. The role of the lookup activity is to read the metadata information from a table or file. Then after that, the metadata information is read and available in an array format in the pipeline, and it can be passed to the ForEach activity that then starts to iterate through that array of metadata/configuration. Then inside of the ForEach, we can have other activities that do some actions based on the metadata. And since these activities are configured by using dynamic content and expression, that allows them to operate very dynamically. In typical scenarios, you most likely would have a copy data activity inside the ForEach, but there could be other activities as well. There are also some other typical variations that can be seen in some implementations. First, we have a pipeline with just ForEach without the lookup, and in this case metadata configuration information is typically passed as a parameter for the pipeline. Then we have a variation with getMetadata activity. In most cases, getMetadata activity is used to fetch child items, meaning files from some folder, and then run pipeline dynamically based on the available files. Next, let's go to Fabric and do some demos to learn more about metadata-driven pipelines there. Here in my Lakehouse, I have these two CSV files, animals.csv and movies.csv. The core difference here is that in the animals files, I have just a comma as a delimiter, and in the movies files, I have a semicolon. So there are slight structural differences between these two files. Then I have this metadata-driven config folder, and in this folder I have this dataconfig.json. And here I have this simple metadata example that can be used to build and instruct metadata-driven pipeline. So here I'm using JSON files, but like I said, in many cases people use, for example, database tables. And my reasoning for using JSON files is that I really like that I can build some hierarchical structure and use complex data types here compared to, for example, database tables. For example, if this information was in a database table, I typically would have to repeat these properties in every row. But when I'm using JSON files, I don't have to repeat them since I have the possibility to use array as a data type here as well. Another point is that I really like how JSON files can be incorporated to the version control and CI/CD processes, but that is a bit more advanced topic. But I think those are some beneficial reasons why you should consider using like JSON files over database tables for your metadata-driven configs. But in this configuration, I have the instructions, what is the source folder, so basically that is the source folder, and then I have the destination layer, that is the bronze. Basically, I'm going to use this as a schema name, so I'm going to create a new schema there called bronze when we write the data, and then this information from those files will be written to that schema as tables. And then I have this datasets array that I'm going to then pass to the ForEach loop and process that through, and there I have the information, what is the source file name, what is the source file delimiter, because they have different delimiters, and then what is the destination table. So this is like a very simple metadata-driven configuration example. And now let's start to build the pipeline that would do the trick with this file. So first we're going to need the lookup activity, and this lookup activity I'm going to configure to get that information from that lakehouse, and we can now only get the first row since we have that array there as part of that single row basically in that file. And now we could browse and find that file. So here we have the metadata-driven config, and there we should have the file that we need. So there's the data config, and we can preview. No, actually we need to change this file format to JSON, otherwise it will fail. But now it is JSON, and now we can preview the data and see that are we able to fetch this data correctly, and we can see that we fetch the entire data set there. And now we could actually try to debug this lookup activity and see that we get that information correctly to our pipeline execution flow, and we are able to use that in the following activities, meaning in the ForEach activity after it has been fetched. Now the lookup has executed, and we can see that we have the first row object there, and in that first row we have all the configuration that we need. So now we are going to basically use this first row here and first get the data sets from that and use this in a for each loop, and then we are going to use this information in the loop and of course the information from the item itself when we loop this through. But yeah, let's add that for each here, and it is there. And then first we are going to need that data set, so let's copy that there and then configure the items here. So we are going to get the lookup activity first row, and from that first row we want to get the data sets because that was the array there. And now we can click OK, and then we need to add that copy data activity there that we're going to configure to copy those files. So we're going to select the lakehouse again, and to the source side we are going to configure this as a delimited text, and then to the directory we are going to use the dynamic content, and we are going to actually get the activity outputs, and from there we wanted to have the information about the raw folder. So from this entire config we now want to fetch the raw folder, since this is wrapped to the first row when we use the lookup, and we want this source folder property there. So I'm going to use .source folder there and click OK. And then to the file name, we want to use the current item. And then for this item, we want to use this source file name here. So it will be the source file name property. So we are able to fetch that. And then we also need to change some delimiter text settings, since we had the different column delimiters in the file. So we need to add some dynamic content here. So we are again selecting the item, and this time we want to get this source file delimiter property from the first row like this. And now that has been configured, and now we could actually try to preview the data by hitting the preview, and then we have to fill in these values to be able to preview can we read the data correctly. So we can try this with the one of the files. And there's the information. Now we can click OK and see that are we able to preview that movies data correctly. So let's see. And data looks good, so I think we have configured everything correctly on the source side of things. We could actually also test it with the other file, but I'm fairly confident that I have configured everything correctly. And again, then to the destination side, we want to configure the lakehouse, but this time we're going to use the table section, and now we are going to enter those information manually here. And actually we can also change the table action to override, since I think that would be preferred in this case. But first, we would need to set the table schema, and for that we are again going to use the lookup activity first row, and for this we are going to select the destination layer from this configuration that we have here. And now we can click OK, and then we are going to set the table name, and for this we are going to use the current item. So basically these were the items, and from the item, we want the destination table property. So we select the item and then use the object notation to get the destination table there. And then we can click OK. And now everything should be configured correctly, and we can try to run this pipeline and let's see if we are able to process those files. So let's first validate our pipeline and see that there are no authoring errors, and then we can hit run and see that are we able to process those files to those delta tables in that lakehouse. And now our pipeline run has been completed and everything has succeeded according to the logs, and we can check out one of the copy data activities and we can see that one file was read and 3 rows were written to the lakehouse, and we can go check out our lakehouse and confirm that we should have now a bronze schema there, and in this bronze schema we should have 2 tables, animals and movies, and let's check out these tables that the data in tables actually look good. And this animals data looks good, and then let's check out the movies data as well. Does it look good as well? So we were able to then process both of these files correctly to their tables, and also the movie data looks good. So our simple metadata-driven pipelines seem to work. And this is just a simple example how you can use this metadata-driven logic to build very efficient pipelines. Because you can, for example, imagine a situation that we would have like a 100 different files here, and you wouldn't really want to build like pipeline with one copy activity per file, because that would be very inefficient, and using this kind of a iterative and metadata driven logic is really a best practice when using the pipeline tool. And like said, using this kind of a JSON metadata configuration is just one way of achieving this result, and there are multiple other different ways, and like I said, one of the popular ways is to use like database tables or delta tables for that configuration information, but I'm a big fan of using these JSON based configurations for the logic. In this lecture, we are going to be learning about best practices that allow us to build more error-resilient pipelines that run smoothly in production. But before we do that, I want to ask if you really learn these topics by just listening me to explain them, or would it be better to get some hands-on practice with all the topics that we have covered here? Well, that's why I have founded a learning platform called Fabric Forge. In Fabric Forge, I teach Maxed Fabric with other brilliant experts, and the focus is on practical hands-on learning, since in my opinion that is the superior way of learning Maxed Fabric. In Fabric Forge, we have many different courses about different topics related to Fabric, and for example about data pipelines, we have currently 13 different hands-on exercises with video walkthroughs, and similar courses from many different topics like PySpark notebooks, real-time intelligence, Power BI, and data agents, to name a few examples. And new courses are being added constantly to Fabric Forge. So, if you want a one-stop shop for learning all about Maxed Fabric with a practical hands-on approach, then Fabric Forge is a place to go. And the best part is that Fabric Forge is currently 100% free to join, and a link to the Fabric Forge can be found in the video description. Also, we offer premium membership to the platform that gives a ton of perks, and one of them is a weekly call with me and other top Maxed Fabric experts that are teaching topics in Fabric Forge. During those calls, we can answer your questions about Fabric and support your learning journey. But now let's cover those pipeline best practices. Okay, now let's talk about some of the best practices with pipelines. And first one is this keep it simple. So basically, when you are using metadata-driven approaches, for example, you want your pipelines to look something like this so that they are not overly complicated. For instance, that you are first fetching your configuration file and then you are iterating over that configuration file and having some type of activities in that for each loop. And after that, you could have some follow-up processing. For example, you have a notebook where you process that data forward. But it is a good practice to keep things simple. And for example, if your pipelines start to look like this or something similar, then you're probably doing something wrong. Because pipeline tool is not meant for building like very complex logic, and it is not really meant for that. If you feel like that you end up to a situation where you would need to use a ton of different variables in your pipelines and have a ton of activities in your ForEach loop and have multiple branches of activities, then you could question it a bit and think about that, are you using the right tool for the right job? Because in Fabric we have so many great other tools, for example notebooks that allow you to write your own code there. And notebooks are really great for some more complex scenarios where you need to build some more complex code, and because you can write your own code there, you can basically do whatever you want. And of course with notebooks and every other tool there are their own best practices as well, so you don't want to build overly complicated solutions with any tool, but basically with those tools you get a lot more flexibility and things are maybe simple to do there than in the pipeline tool. And also when you are building data pipelines with the pipeline tool, it is also good to think about like the logical flow of the pipeline so that it's clear and it can like recover from some error situations. So that like, for example, if you have a failure there, that you wouldn't need to do any manual adjustments to your pipeline to get things working again, and that pipeline would just recover with the rerun. Then there are some settings in the activities that I want you to be aware of and also use. For example, if we think about this copy data activity here, we can see that we have this retry setting. This retry setting is something that can be found in almost any activity that is using some external data store or an external tool. And by external tool, I mean also other Fabric items, for example, notebooks. And what this retry setting here means in practice, that if we haven't specified any retries here and this copy data would fail, for example, there would be some minor network downtime that would prevent us connecting to our source system, then the whole pipeline would fail because the copy data wouldn't try to rerun it itself after a while from the failure. But with this retry, we can actually change that behavior and specify here, for example, 2 retries. This means that if the copy data will fail once, it will retry again, and then if it will fail again, it will retry one more time. So basically retry 2 times after a failure. And if it succeeds, then it won't retry again. And by the way, there is actually a possibility to configure the retry interval under this advanced section. So here we can set the time in seconds, that is the interval for the retries. In many cases this 30-second default is just fine, but in some cases you might want to think about like a longer retry interval there, for example. But I think it's quite a best practice to set at least few retries per activity here so that your pipeline will be more error resilient and recover from those like minor network downtime issues or whatever, so that the pipeline won't instantly fail. And while we are here, it is good to talk about this timeout setting that we have here. By default, that is 12 hours, so this means that our copy data activity will run 12 hours after the timeout will actually end the execution. In many cases, this default 12 hours should be more than enough for the copy activity to do its job. But typically when I'm building pipelines, I think about like what is this kind of like a logical limit for the timeout. For example, if I know that my copy data activity should only take like 30 seconds or so, then I probably want to set this to half an hour or something. Because for example, if that copy data activity would get stuck, and I have seen those situations happen, then that would actually time out after that 30 minutes and wouldn't wait that 12 hours until that timeout happens. But there could be actually some situations, for example, when doing some initial loads for the data, that you might want to specify a longer timeout there if you need to move a ton of data through a connection that doesn't have a great output. So there you can just think about, should you add there, for example, 24 hours if you know that that will be a very long copy, so that your copy data doesn't time out prematurely. And then there is one pipeline level setting that I want you to be aware of and also use. So let's click the pipeline canvas and let's open up this settings tab. And here we have this setting called concurrency. And with this, we are able to configure how many instances of this specific pipeline we can have running at the same time. For example, that we would have a situation that we would run this pipeline every 5 minutes. And this would just process tiny amounts of data. But then we would have a situation that for some reason the run would take a bit longer. So for example, it would take maybe 7 minutes, so that we would already have a new instance of this same pipeline execution starting while the execution for this pipeline was going on. That we can control with the concurrency setting, so that if we would define here 1, this would mean that the concurrency for this pipeline would be 1, and if we have a second instance of this pipeline starting while the other one is still going on, that other one would wait until this has been completed and then start the run. And I would say that it's a best practice in many cases to have this concurrency as 1, because in many cases you don't want to have multiple simultaneous runs of that same pipeline going on at the same time, because that could lead to some very weird situations if you are reading and writing same data at the same time, etc. So you don't really want that to happen. So that you can control with this concurrency setting. Of course, there are some cases where you want to leave this concurrency setting as empty, and those are the cases where you have these like a generic pipelines that have multiple purposes and you're controlling them with parameters what those pipelines do. But I would say that the 2 most common settings for this concurrency is either this one that I would say that is the most common, and then the other one is that you leave this as default, so it is a blank value, so that we could have multiple simultaneous runs of that same pipeline. But that is basically for those special cases where you have this more generic and multi-purpose pipelines that are already quite an advanced topic. That was all that I wanted to cover in this course, and remember, if you want to get some hands-on experience with Maxed Fabric, then Fabric Forge is the place to go, and it can be found at school.com/fabricforge. But now I thank you for watching and see you in the next video.